Ladies and gentlemen, welcome to yet another lesson of circle geometry with me, of course, Mr. M. On this lesson, we'll be tackling the sixth theorem of the circle geometry. Let's get right into it. On this theorem, it states that a tangent is perpendicular to the radius drawn at the point of contact. So now basically what it says, ladies and gentlemen, it says that if I am having a radius and then it meets with what? It meets with a tangent, it should form me an angle of what? Of 90 degrees. And then the word is perpendicular, meaning forms an angle of 90 degrees at a place of contact, obviously, and we say we have terminology that is used, which is a tangent and a radius. And you know the tangent, it touches the circle at one distinct point, and a radius is a small line drawn from the center of the circle to the circumference of the circle. Now looking at what that theorem basically says, it says that you can see this line is a what? Is a radius. So if this radius comes and then it gets into contact here with this particular tangent, it has to form what? An angle of 90 degrees. Right, interesting. So meaning it has to form what? An angle of 90 degrees with this one. And we know if it forms a 90 degrees, it also has to form a 90 degrees this side. Now, ladies and gentlemen, what's interesting about this theorem is that you can also have a diameter, that is in contact with what? With the tangent at this point. And then now your reasoning will not be tan perpendicular radius, but it would be what? It will be tan perpendicular diameter. So if you're having a diameter being the one in contact with what? With the tangent, we are now having what? Tan perpendicular diameter. And if you are having what? We are having a radius being the one in contact with the tangent, we will now be having tan perpendicular radius. Hope that makes sense for all of you. I just need you to be able to identify when a radius is in contact with the diameter, or when not a diameter, with a tangent. And I need you to also be able to identify when a diameter is the one that is in contact with what? With the radius. And always remember, at the place of contact, at this angle now, it will have to be 90 degrees. And that's it, ladies and gentlemen, about this theorem. Those are the accepted reasons. These are the accepted reasons. If you're dealing with what? With the radius being the one in contact with the tangent, you basically use tan perpendicular. This basically means perpendicular. So you use tan perpendicular radius, or you can use tan perpendicular diameter when the diameter is the one that is in contact with the tangent. Now, with that being said, ladies and gentlemen, on the next lesson, we'll be tackling the theorem 7, which states that tangents drawn from the circle from the same point outside the circle are equal in length. Now, ladies and gentlemen, I'm just going to simplify this for you in explanation. It does not also require us to prove it. How interesting. So meaning there's no proof that is required. So now, with that being said, ladies and gentlemen, that's it. Please subscribe for more lesson videos. Thank you for watching. Bye, Danke.